Welcome to another screencast. This one's going to be pretty brief. At least I'd like to think it's going to be. Going to show you some simulations from a program called Starry Night. And if we look, we hit play, we could see that the Earth is performing an action, a movement, and it's rotating on its axis. So as a result of this rotation, we're observing this, by the way, from the moon. Kind of cool, right? As a result of this rotation, if we are on the Earth itself, celestial objects will appear to move across the sky, but they're not actually moving. It's an apparent motion, and it's caused by Earth's rotation. So let's kind of go to here. We're going to set a viewing location, and you see, like I said, promised, we were looking at from the moon. We change it to the Earth itself, and now if we set this as location, we're on the equator, which is 0 degrees north. That was weird. Alright, so this is 0 degrees latitude, right? And now if you look, you can see that the stars appear to move across the nighttime sky. Now, are those stars actually moving? We'll go a little bit back in time. We go backwards in time. No, they're not. They just appear to be moving because the Earth is rotating on its axis. So far, so good? Alright, so if we could change the time frame a little bit too, and we could put this down to seconds. You can see it slows down a little bit, and you could see that little by little the stars appear to move. Is it an actual movement? Nope, it's an apparent movement. We'll speed it up a little bit. It's an apparent movement because the Earth is rotating on its axis. So let's change the location, shall we? Let's go with 90 degrees north. At 90 degrees north, if I hit play, I could jump up in time. You can say, hey, look, there's the sun. Hey, bye, hey. And that's an apparent motion. The sun is not actually moving across the sky. Instead, it appears to move across the sky because the Earth is rotating on its axis. You can see it there again. Hi, wave to the sun. So if we take a look, the date's a little bit off, a lot bit off actually. Today's date is October, and you can see that stars appear to move across the sky because the Earth is rotating on its axis. Now, if I were to look up, this is the zenith. This is directly over my head, and I'm at the North Pole. This little star over here is, come on, Polaris. It's the North Star. It does not appear to move at all because it's directly over the North Pole of Earth. Now it's 433 light years away, which you know is really, really, really far. So it's not directly over there. It happens to be lined up with the North Pole just by pure luck. So these stars that do not appear to rise or set are called circumpolar stars, and they appear to move around Polaris. But that apparent motion, again, for probably like the 12th time, is caused by the rotation of the Earth. So that's what an observer from Earth sees when they look at these celestial objects that appear to be moving, but it's not a real movement, it's an apparent movement because the Earth rotates. So let's kind of look at a little more familiar area, and that is 40 degrees north, and, longitude would be 73.5, but we want west. Oh, it just gave me the 5 because I did try to do, so let's just do 73 degrees west. And now we're in Syosset. Okay, go back down to the horizon, and if I hit play again, you're going to see, it goes pretty quickly, there's the sun. It appears to move across the sky. Notice it's kind of like an arc because the Earth is rotating on its axis. Now, some of these stars appear to rise and set because of the latitude we're at. And hey, there's the sun. Hi. And all of this is caused, it's an apparent motion, all caused by the rotation of the Earth. So here's the constellation Orion, by the way. That's Betelgeuse. Remember Betelgeuse? It's Betelgeuse. All right, so that's Betelgeuse, which is kind of cool and exciting, isn't it? So this is looking into the south part of the sky. That's the moon. It's the northwest, right? All of these motions, if I hit play again, all these motions, let me go back in time, sorry about that. What star do they appear to be rotating around? I wonder. Let's hit stop for a second. It appears like this guy is what? Polaris, aha! And that's also known as the North Star. So I put in 40 degrees north over here. If I were to measure the angle from here, the horizon, to Polaris right over here, it would actually be 40 degrees as well. So whatever the angle Polaris is off of the horizon, that translates to your latitude. We'll talk more about that in class, but how cool is that? And that's how people were able to navigate ships in ancient times. So watch, if I go to 50 degrees north, and I'm leaving it paused, 50, watch what's going to happen to Polaris. Okay, where did Polaris go? Polaris, right? Let's see, put labels in. Stars. See Polaris, watch what's going to happen now. I have to compensate a little bit. I'm going to put in 60. See it? Jump. And then 70. Oh, see, I actually have to adjust because it got higher. And then, of course, what do you think is going to happen? I hit 80. It gets higher and higher in the sky till finally, when we get to the North Pole, which is the highest latitude you could possibly have in the Northern Hemisphere, South Pole will be the highest in the Southern Hemisphere. You see Polaris is directly overhead or at the zenith. Okay, so we'll talk more about that in class. The important thing for this screencast is for you to know that the apparent motion of celestial objects across the night sky is caused by the rotation of the Earth, and that's an apparent motion, not an actual motion. The other thing to keep in mind is that the Earth's rate of rotation is about 24 hours. It rotates 360 degrees in 24 hours. Therefore, if I did it mathematically, it's 15 degrees an hour, and therefore celestial objects appear to move across the sky, and by the way, including the sun, at 15 degrees an hour. The moon at 15 degrees an hour. Arcturus, 15 degrees per hour. Kind of interesting, right? Pretty cool. These are all really important concepts for you to know. I usually like to try and leave you with something intriguing, interesting, funny, inspiring. But this is some park job, huh? Wish I could park like that. Hope you enjoyed the screencast, and I hope you got something out of it. Enjoy your day.